First, the application of big data for traffic analysis. What you see here is a map. You probably know Google Maps, and you probably know that you can have an overlay of your current traffic situation. And that's a traffic situation you see here on the German Autobahn. And you see the different colors on the streets. You see some special signs maybe also. And if you use that, you of course know how to handle that. The red marked streets are the traffic exposed to a traffic jam. For example, a dark one. The dark red here is a traffic jam on this road, on the A72, and the orange ones here in this area, it's slow traffic maybe, and you cannot drive full speed. In the green area everything's okay, so you don't have to think about being late. Here on the right side there's a special sign for some blocked road. So another question is, how does Google acquire all these data? How does Google analyze these data? And how is it possible to present this quite comfortable result to you as the user? And regarding the parts a big data application consists of, I have here these parts analyzed regarding the traffic analysis, for example, for the Google traffic overlay. First, the data acquisition. How are data acquired for this traffic analysis? Everybody has a smartphone. Everybody in the car has a smartphone equipped with GPS. And of course, you are connected to some mobile network via your mobile operator. And this smartphone, if you use Google Maps, for example, a lot of people do use Google Maps, then you continuously sense your position. You continuously also sense your speed of the car you're driving with. And these data, your position and your speed, these are the most important data, are transmitted to a Google Maps related server, because this server then persists first all these data in the data storage. And you could think about a lot of people using the application, a lot of people scanning their position and speed, sensing their position and speed. So this can lead to a large amount of data acquired by many smartphones out there in cars and other vehicles. When the data are acquired, then you need to store the data somehow. You would persist it in a database. Let's say it's a relational database. That would be quite okay. And anyway, you have a large amount of data to store, hence you need to deploy a proper amount of databases. The third part a big data application consists of is the data analysis part. And now comes the interesting part, because there you analyze the acquired data with certain algorithms which somehow should lead to the result that there is a traffic jam on the road, or there's slow traffic maybe on the road. And therefore you need to segment your data, for example in this traffic analysis, regarding the geographical regions, segmented to these different parts, segmented regarding certain street segments, and therewith you're able to assign the data. Which data did we acquire? We acquired the position and the speed. To assign the position and the speed to the correct geographical position, so that you know, at a certain position on your map there's a certain speed which the driver drives their car with, and this then means traffic jam or not. You also need to think about filtering useless data, or data which somehow do not show your real world data. For example, if you have a postal truck which frequently stops on a street because the packages are delivered by the postal worker, then you have data from this truck that he frequently stops and maybe he drives very slowly. But other data on this street might show a totally different view on the traffic situation, because the other cars just drive normally with a continuous speed and without any stops. So in your data analysis part, you have to filter out these useless and distracting data such that they do not contribute to your traffic situation, which you want to then show on your map. And you also have to somehow aggregate the data in this situation, the geographical data of positions and speed. You have to determine the average traffic flow, and when you look at the map, it's not shown that you have a certain speed which you can reach in this segment of the street here, but it's expressed via the color, and the color says the traffic is flowing or the traffic is kind of a traffic jam and it's not flowing that very well. But what is not shown here is the actual average speed. So what you need to determine in your data analysis is kind of average data flow. Therefore, you analyze the speed, you analyze the average speed on the street over all time, and then you somehow relate that to your current speed, which is reached by the cars on this street segment. Next point is you need visualization. You need the visualization to somehow show to the user that there is traffic flow or the traffic is somehow blocked. And this is done with this overlay over the map, which somehow has to fit properly to your geographical map, and you express with colors how the traffic flows. You know the application, it's the navigation for your personal car driving, and you use the color, of course, to somehow do a rerouting if you think that it might be not the best idea to drive into this traffic jam.